Hello guys, welcome back. So in this video we are going to understand this Leetcode problem from the contest 455, right? And this is the last question. So question saying that we have to find minimum time to transport all the individual. Okay, so the if you pause this video and if you'll go through, right, what we have given n individuals, we have given means n people we have given at a base camp, right, who needs to cross a river to reach the destination using a single boat, right? And the boat can carry at most k people at a time, right? Means first of all we have given n number of peoples we have given who want to cross a river. Let's suppose this is a river and this is a boat want to cross, he want to go to a destination, right? So when he want to cross the river, at that time at the camp, how many peoples are there? There is a camp, right? And there is n number of people are there who want to cross this river, right? So there can be on this boat maximum k people can sit and can move into they can cross the river, right? Means first of all we have given how n number of peoples we have given, right, at the base camp. Then we have given what this boat can carry at most how many k people at a time, right? Then it is also saying the trip is affected by environmental condition that can vary cyclically over m stages, right? How many stages will the m stages will be there? Okay, then it is saying that each stage j has a speed multiplier, right? So a speed multiplier means you can say this is the multiplier, right? So this multiplier represents environmental stage multiplier that cyclically affect how fast or how slow the boat can moves in the while crossing the river, right? So the river has m stages. How many stages? M stages is there, and we can say these m stages are environmental stages are there. So this repeats in a cyclic fashion, right? So let's suppose at each stage the crossing time will be what, which is affected by multiplier, right? So we can say if we have multiplier, this one we have, right? So if multiplier at j is what, there can be greater than 1.0, there can be less than 1.0, and there can be a speed equal to what, we can say 1.0. means three conditions can be there, right? If it is greater than this, right, if the speed, you can say if it is multiplied at j, if it is greater than 1.0, it means what, the river is slow and it takes more time to cross the river, right? So the trip will become what, slow, because the river is slow, so it takes more time to cross it, right? When it is less than 1.0, it means what, the river is faster, so it takes less time to cross. And if it is equal to 1.0, right, it means the speed is neutral, right? The river speed is neutral, right? And so there is no effect. Okay, when it is faster, when the river is faster, it will takes a trip will be slow. If it is faster, it means it will take less time, right? So this concept we have to understand here. Okay, now the rules is saying that group G departing at a stage j takes time equal to the maximum of time at I. It means along the its member and multiplied by this to reach the destination. A group G, right, a group of G people that want to cross the river, and so the trip time become what, max of times at I into multiplier at stage. So the slowest person determines the time, understand? Means if we are taking the max of the time, it means the person who is slowest, right, that will determine that one trip will determine the time, right? So each stage is advanced by, so it is also saying after the group crosses the river in time d, right? So the stage advances in, right, floor at d, means floor at time. D is nothing but time. It means it is saying floor at time, and then we have to take mod m, that we are talking about this one, right? So because the slowest person determines the time. So we can say the stage is advances by floor of time into m, right? And not m to m, mod m. This is your mod. Okay. Next condition is saying that if individuals are left behind, one person must return with the boat. It means if the people are still at the base, right, it is not completed, means one person must return with the boat alone, correct? And so it is saying one person must return with the boat, right? And let r be the index of the returning person. So the return takes time at r into multiply the current stage. It means the returning time, this is nothing but what? Returning time. Returning time is time at I is nothing but the people, right? We have to multiply the multiplier at stage, right? So we can say time at I, right, because we are thinking about the time, right? Then we can say mul at stage, we can say that, right? And so it is also saying that we have to define the return type, return time, and stage advances by floor, return time, and then mod. Understand? So these are the rules we have given, right? And so we have to implement it. It is also saying that you can only do 3 single person trip total. So let's understand the example here, right? What the example is saying. Okay, so we have given n equal to 1, k equal to 1, m equal to 2, time we have given 5, multiplier stage we have given what? 1.0 and 1.3, right? Means this is the stage multiplier that is we have given, right? See how fast the boat will move during crossing the river, that we have given. Okay, so if you observe that, right, let's suppose if you are going to understand this, right? So what we have given? We have given n equal to 1, k equal to 1, m equal to 2, and time we have given what? Is 5, and there is multiplier we have given what? 1.0 and 1.3 we have given, right? So output is coming this one. Why? What we have given? There is only one person we have given, right? And the time for the one person is time set 0, we have given 5, right? As you can see, means boat can carry one person at a time, right? Means k equal to 1, the boat can carry maximum one person at a time, right? And what is the environmental stages? 1.0, 1.3. So at mul at 0 and mul at 1, we have given 1.0 and 1.3. So if we'll do cycle, right, what will happen? We'll go from 0 to 1, and then 0 to 1, and then it will go to 0, and so on, right? We can say that it means the initial stage is 0 itself. Understand? So let's understand further. So let's suppose what I'm trying to say, in very first step, right, we'll call it, we can call stage 1, when we are going to send person what? Send person 0. If we are going to send a person through the boat to cross the river, that is called send person 0. At that time will become what? Time at what? 0, and then we have to multiply it by what? You know the multiplier at 0. So this time at 0 will become what? This is given 5, and this is given what? 1.0. So it will become how many minutes? 5 minutes, right? So it is taking 5 minutes. Understand? So now no one left behind and no need to return the trip. There is no return trip is required. So the second stage doesn't matter anymore, right? So 1.3 doesn't require anymore. Understand? So everyone is crossed because there is only one person was there, right? Only one person is there. Understand? So if you read this explanation, you will understand. So individual 0 departs from stage 0 across the time. So you directly multiplying and you are getting this value. So all team members are now at the destination because there is one person that we have already traversed. So total time taken is 5 minutes. Understand? This is very easy, right? Why there is no return? Because n is equal to 1, right? There is no need or no one left at base to pick up, and we are done for the one trip, right? So what we have understand that k equal to n. If k equal to n means everyone can cross in one trip. Understand? And the only thing that matter is the current stage multiplier, right? Then no trip is required, right? I hope you understand. Now understand example 2, right? So let's understand the example 2. So example 2, we have given what? N equal to 3. Then we have given what? K equal to 2, M equal to 3, and then time we have given what? Time we have given 2, 5 and 8, correct? You can see example 2, right? We have given, and the multiplier we have given what? Array 1.0, 1.0, then we have given 1.5, and then we have given 0.75. So this is another array we have given. We can say that means what we have given? We have given 3 individuals. How many individuals we have given? 3 individuals we have given here, right? And at the base point, base camp, you can say how many people are there? 3 people we have, right? So let's suppose the person will become what? How many? We can say person. If we'll say person is 0, 1 and 2, right? So for person 0, how many time required? So it's required 2 minutes. I'm talking about this one, so it will take 2 minutes, right? For person 1, how many it will take? 5 minutes. Person 2 required how? 8 minutes. So if you observe that the board capacity when k equal to 2, so when the board capacity is becoming what? K equal to 2, it means the boat can carry or can take up to 2 people at a time, right? So there can be 3 environmental stages, right? This is neutral, this is slower, and this is faster. Understand? So if you'll talk about the environmental changes, right? So after each crossing or return, we have to update the stage, right? How we are going to update it? Just think. When we are going for this stage, let's suppose, right? It means it is what? It is neutral. When we are going this stage, we are going for neutral. Then we are going for this one is slow, and when we are going for this one, this is faster, right? So if you'll talk about the environmental changes cyclically, after each crossing or return, we have to update the stage. So how we are going to update the stage? So we can say if next stage, right, it will take what? Means current stage plus the floor value, right? That we have seen, right? Floor value of travel time. Let's suppose I'll say time, or you can say travel time, right? And then we are taking what? Mod of m. We can say means but our objective is to what? Give me 1 second. So our objective is to move all these 3 people to the destination, right, in minimum time. And for that, the condition was there, what? 3 rule was there. So each time, or you can say in each trip, either you will go or return, right? So when you are going or returning, we can say that is our trip, either you're going or coming. So each trip is affected by the current stages, right? The multiplier stages. Understand? So if the people are left behind, someone must return. No more than 3 solo trip is allowed. You know, it is also the condition was there, no more than 3 solo trip is allowed. Okay, we cannot allow 3 solo trips, right? So first of all, let's suppose in the very first step we are sending people 1, means we are sending what? Send person 0 at indices what? 0 1, right? And so the stage at this is what? 1.0. The time is what? 2. So if you'll take how many? K equal to 2 people, means we have to consider these 2 and 5, right? So stage is what? 1.0. And if you want to understand the time we have given for 2 people is what? K equal to 2. So we can take 2 people, either 2 and 5. This will be the pair. Which one is the max? You take the max one. Which one the max? 5 is the max. We'll take 5. So the next stage will become what? How many? So the next stage will say from here, what will become? The current was what? 0, right? And so float value will take float of travel time. What is the travel time? Travel time is 5. The float of 5 we have to need, right? We need that. And then we'll take mode of m is equal to 3. So if you observe, we can say 5 mod 3 will calculate, because this is 0, right? And that will come 5 mod 3, and you will get what? 2, right? We can get 2. So now we have to mask after only 2 person is left, right? 0 and 1 are crossed. I mean, which one is left? Only for this person left, right? For 8-1, or you can say person this is left. So 0 and 1 has crossed the river, but only 2 is left, right? And if you observe this, so total time we have taken is what? 5 to cross these 2 people. To cross these 2 people we have taken time is 5. Understand? Now we have to return 1 person, right? Once we have to return 1 person. Why? Because we have to take this person, right? The 2 person 2 we have to take. So person 0 and person 1 is already travel, but in the next step we have to return a person 0 at least. So person 0 we will return, and this time the multiplier stage is 1.5, means it is fastest, right? And so in stage 2, so this is the first step we can say. So in the next stage, what will the value is there? I'll write there directly. Okay, so let's understand. I'll take this one. Okay, so now we are going to send who? We are returning here, right? We are returning the person. So when we are returning the person, the mul add to is what? 1.5, right? Sorry, we are talking about this one, right? So it will become what? Mul add to is what? 0.75. So this will become what? This time it will become 0.75. Understand? Then if you'll talk about the time will become what? We have here we can take 2, right? 2 into, because we have to take the return time, right? So we have to take what? 2 into 0.75, right? And so it will become what? 1.5. Understand? So this will become our time, 1.5. And so the next, if you use the next stage, what will come the next stage? 2 into the float, right? So if you apply this formula here also, let's see, I'll take the formula 2 plus, we'll take the float value, and the float value is what we have given, float value of travel time, and it was 1.5 that we have calculated, right? 1.5, right? And then we have to take the mod m is nothing but 3. how much it will come? It will come this one, and then 2 plus this, right? So it will become what? 2 plus 1, and then we'll take the mod, right? 3, so it will become 0. Okay, 3 mod 3 is 0, right? So if we'll talk about the total time, so previously it was what, how many time? 5, right? We have taken travel time is 5, right? So total travel time till now is 5.5 minute plus 1.5 minute is total is 6.5 minute. Understand? So this time and this time we have to update it, so totally becomes 6.5. now we have to send what? Next person. Let's suppose when I'm going to use the next person, I will use this color. Okay, so person 3 is left, means we have to send person 0, person 0 already returned, and person 2 we will send, right? This 2 is left. This time the speed at 0 is nothing but 1.0, right? So we have to find the max one. What is the max? So 2 and 8 is there. What is the max will come? So this will become what? 8. 8 will become the max one, right? So time that we will take is max is 8 this time, right? So the next stage we have to calculate, right? So we will use this formula, next stage formula, and we have to pass. So current stage is what? Current is at 0, right? 0 plus the floor value will take floor value how much? 8, right? Then we can say floor value of 8 is nothing but 8, right? So 0 plus 8, and then we have to take what? Mod 3, right? So it become 8 mod 3 is nothing but 2, correct? 2. Now we have to mask all the person, and all people has crossed now, right? So what the total time came? So if you add all of them, so 6.5 was the previous one, as you can see here, right? 6.5 minute, and then we'll add the new minute is 8.0. So total if you add, it will become what? 14.5. So if you observe here, you are getting what? 14.5 output in the example 2. So this way you have to write the code, and then you will you have to do the you have to understand the coding, right? You have to step by step, you have to find it, you have to write the code. Okay, right? So we'll use DP in this concept, right? We will use DP concept. In the very first we'll use masking. We have to mask the people, then we have to use the stage. What are the stages are there? Then we'll use the across, it is cross or not, and then we'll pass what? Singles, how many singles we have, right? So these things we have to write in the DP, means we have to use a memoization table to store the minimum time for a given stage, right? And those value we have to write here, right? Means first of all we'll take, let me write it for you, otherwise I will also forget sometime. This is a good way to write the notes. Okay, so first of all we'll add what? Mask, right? Then we'll add you can say stage, right? And then we should add what? Across, and then we'll use singles, right? Like that. Means we have to also track how many people has cross, maximum 3 we can return, right? Single trip. That is why we have to take. Okay, so this DP will store like this, right? Understand? Means our purpose is to write this memoization table to store the minimum time for a given state. Okay, and the, you can say, max time we will write, so that you can say, let's suppose, what is the meaning of this? So we will store the max time, we can say, as a group mask. If you will do the group, let's suppose say mask, right? We can use that, right? So if you want to group mask, we'll store the max time here, right? You know how to find the max time, right? So we have to cache the max time among the people in the group, and that is nothing but our we have to use a group that is called a bitmask, right? That we will use bitmasking, right? Now we have, n, k and m. N is number of people, k is the max capacity of the boat, and m is the number of environmental changes in the stage, right? Then we have given time, the time is base rowing time for each person, and then we have the multiplier stages we have given, right? Now this is the main function we have given, or main method we have given, right? And so we have, first of all, we have to understand about the edge cases, right? So if only one person fits on the boat, it means k equal to 1, but there are more than one person, so it is impossible to move everybody because someone needs to return the boat, but it would lead to infinite back and forth, right? We will go to the destination, will come back to the destination, means return trip, and the on trip will be there, right? So back and forth can be happen, and so it will loop into the infinite. So we have to do what? If k equal to 1 and n is greater than 1, we will return -1. Okay, then we have to initialize these variables that we have defined in the above. Means we want to initialize all those global variables, and we want to calculate the total number of you can say subset of people that is using the bitmask up to the power n we will use, right? I'm talking about here. Okay, then we once we will initialize this, then what we should do, right? So we have to use, we will use you can say initializing the dp, right? How we are going to initialize the dp? First of all, we will initialize the dp, means we will use 40 dp table dimension, where we first use the mask, then we use the stage, then we will use across, and then we will use single. So the mask means we will say like which people are still on the base. Then let's suppose we'll say 0 is 0 gone, 1 at the base, right? Once 0 is gone, 1 is at the base, right? So we have to mask like this, right? Then we can say what is the stage? So this stage is nothing but the current invariant multiplier stage, like in 0 to m-1, right? What is across? Across is whether we are going to the destination 0 or returning 1, right? So we'll take, for the destination we'll use 0, and returning will use 1, right? And this is your single, means number of single person in a group. We can group trip made limited to 3, maximum 3 trip we can do, right? That is our things. So there's that we have to initialize it here, right? Means we'll pass size m, 2 and 4, right? In this case, okay. And once we have done this, right, once we have initialized this, it means what? We'll start the DFS, right? DFS method, right? So we'll start with the DFS method, right? We'll call the DFS method from the full mask, everybody at base, right? At that time base is nothing but what? 0, correct? And so we'll use I, j, a and s, right? So at a stage we'll take j is 0, right? So at stage 0, and we'll use across as a false, right? And then we are going to the destination, single is also 0, right? So we will start from what? I is 0, person is 0, stage is 0, right? And we'll use across is, we will take false, and we'll take because we are going to the destination, and then we'll use single, right? So this is a single trip, right? All those we will initialize this, and we'll say -1.0. okay. So because see, we have to call this, right? And it will internally go for all the people, it will check for all the peoples, right? Now we will do what? We'll create the DFS function, and we'll write the code like this, right? So first of all, we'll check the base condition. We'll check mask equal to 0, we'll return 0, right? If it means if no one is left at base, means mask equal to 0, and we are done, we are not doing anything, we return 0 time. If the single trip is greater than 3, it means we are exceeding the rule, right? Just return the max value, infinite value, right? Means if we are done more than 3 single trip for a person, right? Three single person trip, it means we have to abandon this path. It is too inefficient. We just return it. Okay, then what we will do here, we'll check the memorization check, right? If this stage was already computed, if yes, we'll save this value, right? Or if it is there, we will return the saved value. If it is not saved, like if it is not calculated, we'll return it. Otherwise, we'll continue, we'll send the people, right? So the going across, right? How we are going to check? So let's suppose we have written what? If not across, and then we are passing what? Group equal to 1, it will go till the mask, and then we'll what? Group and mask equal to group, right? And then we'll use the bit count, right? It means we are here trying to find what all the subset group of the current mask is good. Let's suppose we want to try all the subset of the current mask in such a way that group is a subset of mask, means all people in the group are actually at the base, right? And then we'll check if the number of people in the group is less than the k, means board capacity is there, right? That we will check here, and then we'll check the max time group equal to 0, right? It means we want to find the slowest person time in the group, and we will cache it. Okay, then we'll compute the crossing next stages, right? You know how to do this, we have already understand the next stages. So we'll compute the crossing time. So the slowest person time we will multiply with the multiplier, and then it will come the advance stage accordingly. Understand? Then we'll call the DFS again, right here. So you will get the candidate, right? So to call the DFS again, we have to update our mask. Then from the mask you will do minus group. You want to remove the group from the current mask. Then we'll go to the advanced stage, that is called next stage. Then we'll do from true, it will from false we'll mark is a true, means we want to flip across, and we'll say now return phase is there, right? When it is on phase, we'll not do anything. When it is return phase, we'll mark it as a true. Then we will use if this stage, if this was a single person group, just increment the you can say single count. Otherwise return either 1 or 0. Understand? Once these are done, right, we'll go for the return person in the else condition, right? While returning, we have to choose only one person across, not the mask, right? Okay, and so we'll choose any person. We will choose any person across, right? That is we already done, right? Then we'll compute the time, return time, right? We'll compute the return time, and then we'll check, we'll add that person back to the base, that is called bitwise, right? And so we'll do the bitwise, and you will get the candidate, and you know the next stage, right? What you need to do. So it will get the next stage value, right? Advanced value. Then we'll set the you can say again we'll pass the false here, right? We'll set the across for the next DFS call. Once these are done, right, we'll find the which one is minimum, right? And then we'll update it. Once you store the computer result for the stage, then just return it here. Okay, so I hope you understand this problem, and if you have any doubt, please let me know in the comment section, right? So if we want to summarize this, right, just think that the stage is equal to, we'll say current stage at base stage and across stage. We'll return the tip. We'll try every possible group to move up to k, and then we'll calculate the crossing time using the slowest person, right? And yeah, we'll check the slowest person, and then we'll find if the people are left. We'll try all the valid returners, and then we'll use the memoization to avoid the recomputations, right? And we'll keep track of minimum total time, right? And then we'll update our result, right? Understand? Then we'll update our result into the DP, and finally we'll return it. I hope you will like this video. If you have any doubt, please ping me in the comment box, and I'll suggest to write the time complexity, space complexity. If you found calculating the time complexity, space complexity, please let me know in the comment box. Thank you for watching this video, and please like, subscribe this channel. You support directly, indirectly this channel, so you will get premium videos like this. Thank you.